So you, our listener, have sent us some really interesting sources looking at, well, something we all experience. Stress. We're talking about that feeling, stomach drops, heart hammering, like it's trying to get out.
Yeah, and that feeling, that very physical reaction, it's not just random noise. It's actually this ancient survival program kicking in, the fight or flight response.
Mm.
Our mission in this deep dive is really to map out how that hormonal sequence works, why it's so fast, and maybe most importantly, why it causes so much trouble when it gets stuck in our modern world.
It really does feel instant, doesn't it? You get some bad news or you're just, stuck in traffic again, bang, everything tenses up. But what we're really feeling is this like incredibly fast cascade of hormones. Hormones designed for, well, a very different kind of danger.
Exactly. This whole setup evolved way back, think Savannah times.
Yeah.
It's built for one thing, immediate physical threat. A predator appears,
Yep.
and you need instant changes, blood pumping, focus sharpening, energy mobilized to either fight it or run like hell.
Fight or flee. Simple as that.
Simple as that. But the problem today, the real disconnect, is our biology hasn't quite caught up to the fact that most threats aren't physical anymore. A tough deadline, money worries, they trigger the exact same powerful response.
As if it were a lion in the grass.
Precisely. And that's where the danger lies now.
Yeah.
Chronic activation, constantly hitting that internal alarm for things that aren't life-threatening. It's like running an engine way too high all the time. It just wears the system down.
Okay, let's break down how that alarm first gets triggered. Can you walk us through those first few seconds, that instantaneous cascade? How does the body go from calm to red alert so quickly?
Right, so it all starts in the brain. Any information coming in through your senses, something you see, something you hear, even just a stressful thought, if it hints at danger, it gets routed straight to the amygdala.
The amygdala, that's like the emotional processing center.
Yeah, think of it as the brain's first responder, the lookout. It scans for threats.
And if it spots one, what then? Does it send an email?
Much faster than email. It sends an instant distress signal down to the hypothalamus. That's the main command center. From there, the hypothalamus uses the autonomic nervous system to talk to the rest of the body. This system handles all the stuff you don't consciously control, like breathing, heart rate.
Right, and that system has two main modes, doesn't it? Like gears in a car.
Exactly, that's a great analogy. You've got the sympathetic nervous system, or SNS, that's your gas pedal. It hits the accelerator for fight or flight, and then you have the parasympathetic nervous system, the PNS, that's the brake. It brings everything back down, initiates rest and digest once the danger's gone.
So when that perceived danger hits, the hypothalamus just slams down on the gas pedal, the SNS.
It does. That signal goes out through the SNS, straight to the adrenal glands, which sit right on top of your kidneys. And they get the message. Dump epinephrine, what most people call adrenaline, into the bloodstream. Now.
And that's the rush, that's the pounding heart, the quick breathing. What exactly is that adrenaline doing physiologically?
Oh, it does a lot. Very fast. Your heart rate skyrockets, blood pressure goes up. It's literally redirecting blood flow away from things you don't need right now, like digestion, and straight to your major muscles for running or fighting.
Prioritizing pure power delivery. Makes sense.
Totally.
Oh.
And at the same time, the little airways in your lungs, the bronchioles, they open right up to pull in as much oxygen as possible. That extra oxygen gets pumped to the brain, making you super alert. Your senses sharpen sight, hearing, everything's heightened. And for fuel. Epinephrine tells your body to release stored energy, glucose, and fats right into the bloodstream. Instant fuel injection.
You know, what I found fascinating in the sources was how fast this is. It actually happens before the thinking part of your brain, the visual cortex, has fully processed what's going on. That's why you can leap out of the way of a car before you've even consciously thought, oh, crap, a car.
It's incredible biological wiring. Survival first, analysis second. But here's the crucial next step. What happens if the threat doesn't disappear in 5 seconds? The adrenaline rush fades, but maybe the stressors, that difficult boss, the ongoing argument is still there.
Right. The immediate jolt is over, but you still feel keyed up, on edge. There must be another system that keeps things going.
There is. After that initial epinephrine surge starts to wear off, if the brain still perceives danger, a second wave kicks in. This is designed for sustained alert. We call it the HPA axis.
HPA, okay, what does that stand for?
It stands for the hypothalamus, the pituitary gland, and the adrenal glands. It's basically a communication network between these three.
So the command center, the hypothalamus, is still seeing a threat, and now it's activating this other hormonal chain to keep the gas pedal pressed down, but maybe more steadily.
Exactly. It's less of a sudden slam, more of a sustained push. Think of it like this. The hypothalamus, the CEO, senses ongoing danger and sends out a hormone called CRH. CRH travels just a short distance to the pituitary gland, the manager.
Got it. Manager gets the memo.
Right. The pituitary then releases its hormone, ACTH, into the bloodstream. ACTH travels down to the adrenal glands, the factory floor again, and that ACTH signal tells the adrenal glands to release the main stress hormone for this sustained response, cortisol.
Ah, cortisol. We hear so much about cortisol being bad, the stress hormone, but it clearly has a vital role in this HPA axis response. What's its actual job?
Its job is crucial for longer-term survival situations. Cortisol keeps your body on high alert. It helps maintain blood sugar levels for energy, suppresses the immune system slightly to conserve resources, and generally keeps you ready to face the ongoing threat. Normally, once the threat passes, cortisol levels drop, and the PNS, the brake, finally gets engaged, calming everything down.
But the problem arises when that threat never really feels like it passes, right? The low-level chronic stress of modern life.
Exactly. If you're constantly worried, constantly under pressure, that HPA axis just keeps churning out cortisol, the brake never fully engages. And that's when we get back to that engine idling too high for too long. The system starts to break down.
Let's talk about that breakdown, the cost of chronic activation. Where does the damage show up first or most significantly?
Well, the cardiovascular system takes a major hit. Remember those epinephrine surges? If they keep happening, along with elevated cortisol, your heart rate and blood pressure are consistently high. Over time, this physically damages your blood vessels, makes arteries stiffer, and contributes to plaque buildup.
So it's not just a feeling. Chronic stress literally paves the way for high blood pressure, heart attacks, strokes. It's a direct physical assault.
It absolutely is. And then there are the metabolic consequences. This is something a lot of people struggle with. Elevated cortisol signals to your body that you've just survived a major ordeal and need to refuel.
Even though the ordeal might have been sitting through a tense meeting, not actually fighting anything off, so no calories were really burned?
Correct. So cortisol does two main things metabolically. First, it cranks up your appetite. Your brain is telling you to eat, to replenish those supposedly depleted stores. Second, and this is key, it encourages your body to store any extra energy, especially from sugary or fatty foods you might crave under stress as fat, particularly visceral fat, the kind deep in your abdomen.
Wow. So when I'm stressed and suddenly crave donuts, it's not just comfort eating. My hormones are actively telling my body, emergency, store fat. Now, that really explains why stress and weight gain often go hand in hand.
It's a tough cycle. Your physiology is working against your modern reality. And beyond the physical, let's not forget the brain itself. Chronic stress actually changes brain structure over time. It can shrink areas involved in memory and decision-making and potentially contribute to anxiety, depression, and even addiction.
Okay, this sounds pretty bleak, but the sources definitely offered hope. The good news is we aren't just victims of this wiring. We can consciously activate the brake, the parasympathetic nervous system. What are some effective ways to do that?
Absolutely. We have agency here. The key is intentional action. One major approach is called the relaxation response. This was researched heavily by people like Herbert Benson. It's designed to be the physiological opposite of fight or flight.
And it's not just about thinking happy thoughts, right? There are actual techniques involved.
Yes, specific techniques. Things like deep, slow abdominal breathing, focusing your mind on a single calming word or phrase like peace or calm, visualizing a tranquil scene. Even repetitive mindful activities like yoga, tai chi, or prayer can trigger it. The goal is to interrupt the stress cycle mentally and physically.
And there's real data showing it works, particularly for things like blood pressure. One source mentioned a study with hypertension patients.
That's right. They found that after just 8 weeks of practicing the relaxation response regularly, a significant number of patients, I think it was over half in the study group, saw a meaningful drop in their systolic blood pressure, more than 5 points. That's a powerful evidence without medication.
Definitely. It shows you can literally train your body to apply the brakes. What else works?
Physical activity is huge. If you feel stressed, even going for a brisk walk can make an immediate difference. Why? Because you're actually using some of that mobilized energy and glucose.
Right.
It helps release muscle tension, and the rhythmic movement and deeper breathing naturally calm the nervous system.
I find that even just getting up and walking around helps release that tightness in my neck and shoulders. It's like my body goes, oh, okay, we moved. The danger must be lessening.
Exactly. And that's why movement therapies like yoga, tai chi, or qigong are so effective. They combine the physical movement with controlled breathing and mental focus, deliberately shifting you into that calmer, parasympathetic state.
Okay, one more key area the sources highlighted was connection. Social support. How does having good relationships help buffer stress?
It's incredibly important. Having people you can talk to, rely on friends, family, supportive colleagues, acts as a significant buffer. There's something called the buffering theory. It suggests that this social support doesn't necessarily stop the stressor from happening, but it cushions the blow. It helps you cope, provides perspective, and reduces the feeling of being overwhelmed and alone, which lessens the overall physiological impact. It literally helps you weather the storm.
So, wrapping this up for you, our listener, we've journeyed through the brain's alarm system, amygdala to hypothalamus, triggering the immediate adrenaline rush via the SNS and the sustained cortisol response via the HPA axis. We've seen how this ancient system, designed for short bursts of physical danger, can wreak havoc when constantly activated by modern, often psychological stressors damaging hearts, changing metabolism, impacting mental health.
But the crucial takeaway is that you're not powerless. You understand the mechanism now. You know about the gas pedal, SNS, and the brake, PNS. And you have tools, conscious breathing, the relaxation response, physical movement, social connection. To actively engage that brake, you can learn to manage this system and build resilience.
So think about this. That stress response evolved for tangible physical threats, a predator you could see and fight or flee from. Yet today, your body reacts with almost the same intensity to an overloaded inbox or a worry about the future. If deliberately engaging the brake is key, here's something to consider.
How can you consciously reframe some of those common non-physical stressors you face every day? How can you signal to your own nervous system that actually this email, this traffic jam, this worry, it isn't a saber-toothed tiger? How do you convince your internal command center that it's safe to ease off the gas, to let that engine idle down before it wears itself out? That's your challenge until our next deep dive.